In this equation, in this video, basically what we are trying to cover is the two very different and difficult scenarios that the students face when they are finding the equation of the plane. So what they ideally give you is that they give you a plane, and obviously they give you a line in the plane, and the second line that they say is parallel to the plane. So the second line that they are giving is basically not in the plane. They say that it is parallel to the plane. Now, how do I find out the equation of the plane out here? So now if you look at this diagram, consider the top view of those lines. The top view of the, actually, if I take a picture from the space, the top view of the, let's say, first line will look something like this. And if I take the top view of this, let's say if you're clicking a camera picture from here, you take the second line, something looks like this. So even though they are not in the same plane, but when you take the cross product, it is still perpendicular to the plane. So when you take the cross product of both the direction vectors of the lines, you still get the normal to the plane. So in such cases, what we have is we have choice for A as this. Then you take the cross product of -2, 1, and 0 with 2, 1, and 5. And so this is basically what we get is the normal. So normal to this plane, you can see is the 5i plus 10j minus 4k. So this is your normal to the plane. And now for the, as far as the point A is concerned, what we have is we have this. A is 1, -1, and 2. So I take r dot n. When I do r dot n, I get, let's say, 5, 10, and -4. Dot product with x, y, z equals to a dot n. So that's a is 1, -1, and 2 dot product with 5, 10, and -4. So order doesn't matter whether I keep this here or this here as far as the dot product. Now, when you simplify this, the left-hand side is this, and the right-hand side is here. So this is your equation of the plane. So 5x plus 10y minus 4z equals to -30. So that's the equation of plane. Now, in some cases, what might happen is that as far as your dot product, the position vector, the direction normal vector can be taken as multiple. So let's say if I take multiple of normal vector, which is like, let's say 10, 20, and let's say -8. So 10i plus 20j minus 8k. Still, this equation is going to come the same. Okay, so in that case, probably it'll be 10x plus 20y minus 8z equals to minus 26. So still it's the same equation. So that's what I'm saying is that you can take scalar multiple as the direction of normal. Now, second difficult scenario that we students get is this. Now, when you have two lines in the plane and you wanted to find out the equation of the plane that contains these two lines. So here, it's actually not very difficult. If you see, this is my first vector in the plane. This is the second vector in the plane. You take the cross product of these two. So take the cross product. And this can be chosen as the A value to find out the equation in the final range. So once we get the cross product of, let's say, 2, 1, and 3 with 2, 1, 1, this is your normal. So let's say I assume that this is, let's say, A1, A, B, and C. I assume the normal is A, B, and C once you do the cross product. So your equation of the plane will be AX plus BY plus CZ equals to ABC. I can take dot product with either 1, -1, and 1, or I can take dot product with 6, 1, 3. So whatever the answer you get, that's the equation of the plane. I have just written in generalized form because I don't know what's the answer for this. So this is how you find out the equation of the plane in different contexts. And next video is on application of the planes.